Hi, welcome to the course of statistics. In this lecture, we're going to talk about the statistical graphs, the types, what type of the statistical graph we need to use in a various situation, the similarities and the differences. So if you've got the huge data sets, we can summarize them using so-called frequency tables, where we are going to count the belongings of the different data items into the different categories or different classes. So the frequency tables are really powerful. They are going to tell us about the distribution of the data points, but the graphs, statistical graphs, are even better and easier tools for us to make the analysis over the data. So let's say I've got the frequency table. So this frequency table is created for the data measurement of the 40 females, pulse rate measurements of the 40 females. So this table tells me that out of 40, 12 females have the pulse rate between 60 and 69, 14 of them have the pulse rate between 70 and 79, 11 of them have the pulse rate between 80 and 89, and so on. So if I would draw this table graphically, what I would do is naturally, I would just put lots of bars. So I would just put the bar for the first class, for the second class, for the third class, and so on, where the height of the bar would mean the frequency of that class. And this kind of graph is called the histogram. So where the height of the bars are going to mean the different frequencies. And for the histogram, it's super important that the classes which are on the x-axis are put in order. So they should be sorted in, for example, increasing order or in decreasing order. So this is another example of the histogram. So which corresponds to this IQ scores of 110 respondents. So we measured the IQ of the 110 people, and 12 of them have the IQ scores between 50 and 69. So if 24 of them have the IQ scores between 70 and 89, and so on. So if I just put the graph, the histogram of this data, I see that the distribution of the IQ scores over this respondents has the normal distribution, which is pretty much normal. But if I would just flip around one of the bars, for example here, I'm not really changing the data or the frequency table, right? I'm just drawing this wrongly. So by putting one of the classes before the another one. So here you can see that 90, 109 class is coming before 70 and 89. So it means that the classes are not sorted. So this basically is the wrong histogram because it doesn't tell us about the shape of the distribution of the graphs. So basically, it's super important for the histograms that we put the classes in the sorted way. For example, an increased way or a decreased way. So in this case, we will see the distribution of the points. For example, in this case, we see that the distribution of the points is normal, but in the different cases, it might be different. So another type of the graph is called the bar chart, which is very similar to the histogram. For example, so this is the graph which shows us the number of the cases of some certain disease in the different countries. For example, in Japan, I've got like 7,000 cases of this disease. In Korea, it's like 11,000. In Singapore, it's like 3,000. In Russia, 20,000. In Uzbekistan, it's like 1,000 cases of a certain disease, and the bars are going to basically are really good if I would like to compare the two different categories, right? For example, here from this graph, it is clear that the number of the cases of the spread of a certain disease in Uzbekistan is much lower than in other countries. So do you see? So the bar graphs and the histograms are basically driven using the bars, and how to find their differences and so where we need to use the histogram and where we need to use the bar chart. So the bar graphs are basically used for the qualitative data, right? So where we count the number of the belongings of the data sets into the different categories, where the categories are qualitative, like a cities or like a colors, the countries, and so on. And the order of putting them is not really important. For example, you can just flip around. So we've seen this graph previously. We can flip around Uzbekistan with Japan. First country was the last country in this list, and it doesn't really matter because we are using this graph not to see the distribution of the graphs, right? So we are using this graph in order to compare the two different or multiple different countries in terms of the spread of a certain disease. While the histogram is used for the quantitative data or the classes. So when we go through the data points and construct the frequency points, the classes which belongs the data points have the numerical values, and we can sort those classes. So the classes are sorted, so that is why we can see the distribution. So the main purpose of the histograms is to see the distribution of the graphs. So again, so the histograms, we need the histograms in order to see the distribution, but yes, sometimes just looking to the graph using the bars is difficult for me to see the distribution. The idea would be maybe to just connect them using some lines, right? So I've got the points on the top of the bars. So the height of the point basically means the frequency of a certain class or the category. Then I will just connect all of those points. And actually I don't need the bars. So this type of the graph is called a polygon. In this case, it's a frequency polygon, where I put the points depending on the frequencies, and we are going to just connect them using the straight lines. So this type of the graph is also very useful when we would like to see the shape of the distribution of the data points. So this is very similar to the histogram, but sometimes it's better for us to see the distribution using their frequency polygons. So there is another type of the graphs, which is called a stemplot, which represent the quantitative data by separating each value into the two parts. So to the stem part and to the leaf part. So I would like to explain here what does it mean in the following example. So this table contains the measurements of the pulse rate for the 40 males. And I would like to write this down, not into the like a standard frequency table, but to the stem table or stem plot. So in order to do this, I would like to choose the first value, which is 56, okay? And I would like to split this into the two parts, like it's tenths and the units. So in this case, it's going to be 5 is going to be the stem, and 6 is going to be the leaf. So stem and leaf. And I would like to do this for all of the data points, and I would like to put them into the table where I would like to write down the stem separately and the leaves separately. For example, for the 5, I will have the 5 as a stem and 6 as a leaves. So I've got here the 2 6s because if you look to our data points, on the pre-last column of the third row, I have another 56. So inside this data set, I've got 256. So I would like to write down the 256 as a 5 as a stem separately and 6 as a leaves. So what we're going to do is we're going to do this for all the other data points. For example, for the 64, I would like to split this to the 6 and 4 separately. 68 is going to be split into 6 and 8 separately. So we can do this for the 6, for the 7, for the 8, and for the 9. So here, if you look to the second row of the stem plot, you can see that 6 and lots of zeros. So all of the zeros doesn't mean like a 60 or 600,000. It means that I've got the data point 60, 60, 60, 60, 65 times. So this type of the graph is very useful if I would like to see the number of the data points which are different in order of magnitudes. For example, I would like to know how many points are in order of magnitude of 1,000 and how many points are in order of magnitude of 10,000. So in the situations, we need to use the stem plot. So now, sometimes, okay, so I've got the frequency table, which is going to be, let's assume that this is the spread of some disease in our country over the time. For example, in February, there were like 12 cases of this disease, in March, 14 cases, in April, 11 cases, in May, 1, in June, 1, in July, 0, in August, 1. So what I would like to do is, so this is the small table, which is super clear for me that the rate of increase is decreasing over the time, right? But if the table is huge, I would like to understand how the rate of the increase or decrease is changing, okay? So I would like to understand how the rate of the spread of this disease is changing over the time. So in order to do this, first of all, I would like to draw the cumulative distribution table. The cumulative distribution table basically sums the frequencies until that point. For example, 12 until the February, until March, I will add the 12 to the 14. Actually, it's going to be 26. So there is a typo. So until April, it's going to be 26 plus 11. It's going to be 37. Until May, it's going to be 38, and so on. Okay, so there's a mistake. So let's assume that this is the cumulative table. So where I would like to add the values, the frequencies until that point. So the graph, which corresponds to the cumulative distribution table, is called an Ogive. So this is the very similar to the frequency polygon. So I would like to put the points which corresponds to the frequencies of the cumulative table. Then it really clearly shows for me how actually the speed of the spread of this disease is increasing or decreasing. So from here I see that until after April, it's not really increasing, right? So we need an Ogive if I would like to understand the rate of change of something. So an Ogive is used for the cumulative frequencies, and it's mostly used if we would like to understand the rate of change of something. Good. So another type of the graph which we use to understand the distribution, the shape of the distribution of the data points, is called the dot plot. So previously we used the two different types of the graphs to understand the distribution. One is called the histogram, another one is the frequency polygon. So this one is called the dot plot. So here I see that there are 12 appearances of the February, right? So the frequency of the February is 12, means that if I would draw this using the histogram, for example, I would draw the bar whose height is equal to 12. So now what I would like to do is I would like to put the points depending on the frequencies. And for example, for the February, I will put the 12 points which are stacked on the top of each other. So here, so for the February, I'm going to put 12 points because the frequency of the February is 12. For the March, I'm going to put the 14 dots because the frequency of the March is 14. For the April, we're going to put the 11 dots because the frequency of the April is 11. So the dot plot contains the dots. If one of the value is repeated twice or so times, multiple times, we're going to put the dots on the top of others. So this also tells us about the shape of the graph, right? So sometimes it's better because whenever we see the histogram with the bars, it's not so clear what exactly the height of the bars, right? So without the table, it's very difficult for us to think about the conclusions very technically because we don't know exactly the values, or sometimes it's really difficult for us. But with the dot plot, it's very much clear how many frequencies, so what's exactly the frequency of that category. So again, the dot plot is used in order to understand the shape of the distribution. So whenever we would like to understand how 100% of something, some weight, is distributed over the different categories, then we use the pie chart. The pie chart is a circular chart which is split into the different categories depending on their proportion on the 100% of the weight. Okay, so let's assume now, so I would like to sell the ice creams. So I have a truck where I sell the ice creams. What I did is I counted for how much I sold the ice cream in the particular day, and I also noted the temperatures. So I've got this table, so which is not the frequency table anymore, right? So by just looking to this table, I would like to understand whether there is a correlation between the temperature and the ice cream sales, basically whether so I'm selling more ice creams if the temperature is higher. So if my table is huge, it's really difficult for me to understand this. And so far, we've learned about lots of graphs which are about drawing the frequency tables. And this table is not a frequency table. And the purpose of this graph, the new type of the graph, which we're going to learn now, is also different. So now I would like to understand whether there is a correlation between the two things. So in order to understand this, what I would like to do is I would like to draw the two axes. One axis is going to be the temperature. Another axis is going to mean the sales of the ice creams. So what I would like to do is I would like to go to my table, one column by one column. And let's go to the first column, for example. So in the first columns, 14.2 and 215 is going to mean the coordinates of a point. So I would like to put a point which corresponds to the 14.2 on the x-axis and 215 on the y-axis. Then we are going to put another point which corresponds to the 16.4 on the x-axis and 325 on the y-axis, and so on. So every single column is going to be the coordinates of a point, and this type of the graph is called a scatter plot, when the data points are coming in a pair of x and y axis, and I can put them on the x and y axis in order to understand whether there is a correlation between the two things or no. So from here, I see clearly that as the temperature is increased, the sales are also increased. So basically, I'm selling more ice creams if it is more warmer or hotter outside. So later on, we're going to talk about something which is called the correlation coefficients, or so it's really important for us also to calculate quantitatively whether there is a correlation between the two things or no, and if the correlation, what is exactly that correlation. So later on, we're going to learn about the trends of that correlation, and we can draw the regression line, which is going to help us to predict the new values. So for example, by knowing the temperature, I can predict how much revenue I'm going to get by selling the ice creams. So the scatter plot are, so it's useful when we would like to understand the correlation between the two things. So let's summarize all of the graphs. So if we would like to see the shape of the distribution of the graphs, we need to use the following graphs, like a histogram, or the frequency polygon, or the dot plot, are going to tell us what is the distribution of the data points. So if we would like to understand whether there is a correlation between the two phenomena, then use the scatter plot. So for example, if I would like to understand how the sales are changing depending on the temperature, we can use the scatter plot. Or for example, if you would like to understand whether the number of the hours you spend before the exam to learn the subject and your grade, right? So you can get this data for lots of students and put them as a scatter plot and try to understand whether there is a correlation between the number of the hours which you spend to exam preparation and your results. So then using the regression line, we can understand what is exactly the correlation between the two phenomena and use this line in order to predict the new values. So whenever we would like to understand the rate of increase of some phenomenon, so how the spread of the disease is increasing, how fast it is increasing, then we need to use an Ogive, which is the graph for the cumulative distribution. For example, if I would like to understand how some disease is distributed over time, I can use the cumulative distribution table, and its graph is going to be an Ogive. So if you would like to understand how the total weight, 100%, is split into the different categories, then you need to use the pie chart. For example, in this example, it shows us how the 100% of your grades is going to be distributed over the different types of the assignments. So all of these graphs are very powerful if you use them properly. So depending on the data type and depending on your purposes, you need to use the different types of the graphs. But even if you choose the proper type of the graph, so sometimes the technical problems may lead you to the wrong impression. So let's consider one of the toy examples of how you may construct the bed graph. So one of the problems of the graphics is not using the zero axis. For example, so let's consider the number of the votes given in the U.S. Congress to the new project of the law. So I've got this data, and I asked this program to draw me, and this result. Basically, it tells me that 62% of the Democrats are agree. I agreed with the new law project. 54% of the Republicans are agreed, and 54% of the independents are agreed with the new law project. So if I look to this graph, which is automatically generated by this program, it looks to me that the Democrats, so the percentage of the Democrats, it's much more higher than the percentage of Republicans. But if I look to the numbers, they are not so much, right? So if I look to the y-axis, it starts from the 53 and it ends in the 62. So let's make it from 0 to 100 in order to see the real differences between the two categories. So if I start this from the 0 until 100, I see the difference is not so much. So basically, using the different excess values for the y, we can basically exaggerate the differences. So this is one of the examples of the bad graphs. No matter how, so basically for us, it's really important to choose the proper graph in order to interpret the data cells, data points, and it's also really important for us to draw those graphs in a correct way.